Assalamu alaikum warahmatullah. Welcome everybody to Practical Numerical Methods for Scientists and Engineers, Ahmed Al-Khattat. And today we have Module 5, Descriptive Statistics and Regression. So let's start with Descriptive Statistics. So descriptive statistics include methods to measure the central tendency like arithmetic mean, geometric mean, logarithmic mean, median, mode, and also other methods to measure the spread like range, deviation, mean deviation, variance, and standard deviation. So let's go for more detail. Now, if I have like a set of data and I want to measure the central tendency in terms of arithmetic mean, so it can be done by sum of collection of numbers and then divided by the count numbers in the collection. So this means x1 plus x2 plus until xn divided by n. Now if you want to measure the geometric mean, to find the geometric mean is similar to arithmetic mean, but it's used for different category. If you have like set of data, like for example you have data like this, okay, and other set, okay, so we have two groups and you want to find the mean of them, okay, so you can't use the arithmetic mean because they're different groups, each one has its own weight. So the better one is to find geometric mean, and geometric mean is x1 times x, the nth root of x1 times x2 plus times until xn. Okay, we also have logarithmic mean. Logarithmic mean is applicable mostly in when the data has a trend like this, okay, curve or quadrupola. So now if you want to find the mean of this data, so the best way is to use logarithmic mean. So now you can find, if you have this point and the ends, okay, you can find the point exactly here, and it's applicable in engineering problems involving heat and mass transfer, because if you have the driving force, it would be like this, okay, or like this. The driving force, the concentration or heat when from higher concentration to lower concentration, it take shape or curve like this. So it only also if you want to, for example, to find the average between 2 points, so it's better to use the mean bulk temperature or mean bulk concentration. Okay, and so the formula, it will be x1 minus x2 over ln x1 over x2. Median is the middle value among of numbers, provided that you put them in order from the lowest to highest. So if you have a set of data and you want to find their median, so just order the data from the smallest value until the largest value, okay. So the center or the data in the middle, the value in the middle is your median. If this is if you have like even number, but if you have when you have odd number, but if you have even number, then take two values in the middle and find their average. Okay, mode is the value that occurs most often. So if number in the list is repeated several times, so you can it represent the mood of the of your data series. But if you have if the number in the rest it's no repeat, okay, then your list has no mood for it. Here we have measures to measure the spread of data. So for example, we have a range. Range is the simplest way to measure the spread of data, and it's the x maximum minus x minimum. Also we have deviation, and deviation, it means the difference between the observed value and the mean. So if you have like some scatter points like this, okay, and this point is the mean, so the difference between any point and this mean is the deviation. So x average minus x of the observed value of the variable. Also we have mean deviation. For mean deviation, it's the mean of all deviation, of all scatter point deviation, so it will be summation of x mean minus x of the observed variable over n. Now for the variance, since you want to measure the variance, so it divided by the degree of freedom, okay, squared divided by degree of freedom for good estimate. Okay, and the standard deviation is the squared root of the variance. Now we'll start with regression. If you have like set points data set, okay, and you want to make a correlation between the independent x and the dependent y, so you want to find a function, so function that fit this data but no need to match every point, so you have to just general trend of this data. So you can use regression. We have different types of regression. We have a linear, polynomial. So for linear regression, it's just a straight line between them, and we have more um, more orders for polynomial, second, third order or higher. So for second order it will be one curve, third order two curves, and for order 3, so and so on. Okay, the maximum order of equation is n minus 1. So if you have only two data set, x here, x and y, and you have only two, so you can only find linear regression. If you have 3 points, then you can find linear or second or the first or second polynomial. If you have 4 points, then you can up to third order polynomial. Okay, also we have like more complicated nonlinear, like exponential, power, and gross rate equation. So in order to make to find the regression for them, we have to linearize them first, and then we can get the regression. In linear and polynomial regression, we will compute linear and polynomial regression numerically. We also will use how to use calculator to compute them, and how to quantify the error of linear regression, and how to linearize the more complicated relationship. So let's go for each one of them. Okay, numerically. Now suppose that you have set of data x and y, and you have number n of data 1 2 3 4 until n, and you want to find the correlation. This is the independent and this is the dependent one, and you want to find a correlation between them using this equation. So in order to make this, you can apply the following matrix. So now the n, if you have for example 5 or 6, so the n will be 5 or 6, then you can find the summation of x, summation of y, and then you can make create another cell x squared, okay, and another cell xy, okay, and then find the summation. Once you input them here, so you can solve the equation for the two unknowns and find the a1 and x2. You can use it either by calculator, or you can also use it directly using the Excel For the Excel, you can use the you can suppose this is matrix A, and this is matrix this is vector X, and this is vector B. So you want to find X. So using MATLAB, you can X equal A, sorry, A backslash B. Okay, and using Excel, you can use special uh, function that convert A to A minus 1 and then times B, so it will give you X as well. Okay, I will show you in detail how to make every one of them. Okay, and now let's take example. So suppose that you have like this table and you want to find X, the correlation linear regression for X and Y. Okay, remember that this is our matrix. So now we create a table that contains X, Y, XY, X squared, and we find the summation of all points. Then we have this matrix. Then we can solve it, as we said, by even by calculator, Excel, MATLAB. For Excel, you should use M inverse or M and M multi, and I'll show you in detail how to use them. Also by calculator using equation and linear equation. For polynomial, okay, it's similar like linear but more complicated, little bit complicated. Just I want to give you some hints here. Okay, now since we have two coefficient to find, then our matrix here should be 2 times 2. Okay, remember that here we have order of increasing the X. Okay, so we have X power 0, so it n. Then here we have X1. When we go for the next row, we'll start with the diagonal, so it will be summation of X, then higher X squared. And the left hand side we have Y, and then we have also increasing the power of X, so it will be XY. Maybe it's not clear here, but when you go for the different polynomial, it will be more clear. Now we want to find 3 vectors, so create matrix 3 of 3 n. Then we have summation of X, we have X squared, it's increase, go for diagonal here, X squared, X cube, again diagonal, X squared, X cube, X power 4. And here we have increase of X, so Y, we start with Y, XY, X squared, Y. Okay, I think now if we go for the third order, you can find it easily. So we have okay, 1 2 3 4, so you have to create 4 matrix by 4. Okay, and then we have n, x squared, x cubed, and as well we start diagonal from x until x cubed, and then diagonal from x squared until power 5, and then from cube until power 6. And here you can find clearly x, y, xy, x squared, x, so the power of x increasing here. If you want to find the fourth order, fifth order, sixth order, you can easily make it on by similar way. Okay, now as we said, for more complicated numerical, it's difficult to calculate each of them, to find x squared summation x cube. So, and you may do some mistakes. So Excel, calculator have a good function that you can use to find the summation by calculator. So how to do this? Okay, now go for mode. So let's make a pointer here, pen. Okay, in color, let's take the blue one, and let's take the pointer option as pen. Okay, now so suppose that mode, okay, sorry, okay, I don't know what's the mistakes here. Okay, pointer option pin. Okay, now okay, again we mode and 3, so we can go for statistics. Okay, then we have this screen will show. So if you have two data, x and y, you can either use it depends on what how the regression you want. Here the linear regression, here second order, exponential. So it's up power, for example. So now we are mostly we want for polynomial or linear. So you can select, for example, if you want to for polynomial, for example, if you select 2. Okay, then you have this screen. You can put your data x and y, and make sure that after putting all your data, press AC to save the data to calculator. Then to recall to call this data again, so shift and 1. Okay, so this screen will show. Then when the screen show, you can press 3 to go for the summation screen. Then you can press the number to find which one you want. Okay, this step to calculate to find the matrix you want. Okay, then after that, you can, since you created your matrix, you can solve it by calculator as well, or by Excel, or by MATLAB. So let's go for MATLAB for Excel first. We can use M inverse and M mult. M refers to matrix, so this is special function in Excel for Excel to do calculation on matrix. Again, we said we have 3 matrix here. Okay, so we have A, and we have X, and we have B, and we want to find X. So first we have to utilize M inverse matrix to A, to convert it to A power, to inverse the matrix to A power -1. Then after that, we'll find X through use the M mult function to multiply X minus 1 times B, so we can find X array. Okay, so let's apply this. Okay, now create your matrix first, then you can convert it to inverse the matrix. So first choose you have to select the similar length matrix. So, and then after that, go for function here, equal M inverse, open the parentheses, and select the matrix you want to inverse. And after you select it, then Control Shift Enter. So when you Control Shift Enter, so directly this data will be shown here. Okay, now you can also put the D or B, the right hand left variable. Then you can here also similarly you can select data, select 3 cells, and then go for function here and write mmult, open parentheses. So it will give you can put the 2 variables between comments. So select first one, comma, select the D, and then Control Shift Enter. So directly it will give you the X. So by this way you can find the use M inverse and M mult. Okay, now also you have your matrix. Okay, and since you have your matrix, you can use also calculator to find it. So go for mode and 5 equation, then go for okay for 1. Okay, So then you have this matrix, so you can put your data. So suppose we have the two matrices combined together because you want to solve. So it will be, you have to 1 2 3 4, and here x, and here we have b1 and b2. So this matrix is 4 items, 1 2 3 4. So 1 2 3, so 1 2 3 4. Because we used this one, we use it for 1 2, no, 1 2 3, yes, 1 2 3, sorry, I'm so sorry, it's 1 2 3, yes. So 1 2 and 3, and then also for the second row 1 2 3. So it will be, find the unknowns will be 3 and 4.2. so this is way to find the to solve the matrix using calculator. Okay, now let's take same example but using MATLAB. So MATLAB is much easier. Okay, so we can use polyfit. Okay, polyfit is built-in function in MATLAB to find the codes, the coefficients. Okay, so now we put x and we put y, and then we create the function polyfit x, y, and 1. 1 is the number of order. 1 means first order. If you want second order, you put 2. If you want third order, you put 3, and so on. Okay, but here the answer, make sure that the MATLAB puts the coefficient in order of higher coefficient. That's mean here the higher, this means the x, and this is a free. So I mean, if you have more polynomial, so the order, if you have a number of set, for example 5 3 2 1, suppose this is the answer, then this will be for, this is for a naught, this for a1, this for a2, and this one for a3. Okay, so it's in inverse way. So make sure, because now you can you maybe ask if I give you like this answer or this answer, I ask you to create the equation. So you have to make sure the equation in this order. Okay. Okay. Now, how to quantify the error of linear regression? Now we have two ways to define using R. This is a R squared, coefficient of determination, and correlation coefficient R. Okay, so in Excel you can find R using trend equation. If you have create a trend line and find R. Okay, but how to calculate or how to find them linearly? Okay, so now R squared is the squared of true variance. Okay, and SR is the summation of regression variance divided by squared of true variance, and then correlation coefficient is the root of this one. So how to find each one of them? So now ST is the squared of true. Okay, it's true variance. So we can here find, we have first to find the y true minus y average squared. Okay, so what's first, we have to find the mean of y. Then after that, find the variance of each one, find the summation of all, so it will give me the ST. Okay, also we have SR. SR is a regression, same by regression. So now we have true. Okay, and we want to find the regression. Suppose that you have here we have x, we have we have x, we have y. Okay, this is y. Okay, then once you find the average of y, okay, you can find SR. So find the uh, um, variance for each one from the mean, difference between mean squared from the mean, and then find the summation. And regression, you have first find y regression. Okay, y regression is based on the coefficient you already got. So you already got a, and you got a naught and a1. Okay, a naught and a1. Use this coefficient to create y regression, and then find the variance between y true and y regression, squared of them of all, and then you can find SR. Then you can find ST minus SR or over ST. You can find coefficient of determination, and the root will be correlation coefficient. So now let's make a example. Let's take an example. So calculate the correlation for this table. Remember that this is our formulas. So now for the first step, to find the mean of y. So the summation of all y divided by the n, it will be 13.5. Now to find the st, it will be, as we said, the summation of all variance true minus mean. So it will be 3 minus 13.5, then squared, then 9 minus 13.5 squared, minus plus 10 minus 13.5 squared, until last point 26 minus 13.5 squared. So this is the summation will be 321.5. Now after that we create another y for regression, okay, based on the coefficient a0 and a1, and we can find SR will be S true minus S regression minus 2. Just one point here, you can no problem if you put mean minus y true or put y2 minus n. It doesn't affect, because we have squared. That squared will remove the negative if there is negative. Okay, go again here. So we have y true minus y regression squared. So then the summation of them will be 12.5. Then r squares will be the st minus sr over st. So it will be 0.96, and then the root, it will be 0.98. We can also use the calculator to find the correlation of coefficient. It's a very easy and direct way. So from the stat, now go for mode, okay, and 3 to go for statistics. Then again you can find your equation, if linear or polynomial. Put your data again, then again stat and shift and 1 to go for the screen, and then press 5 to go for regression properties. In this regression properties, we have multi options. We can find A and B. This is the coefficients a0 and a1. We also can find R. R is the correlation coefficient. Also we have 4 and 5. For this one is to find to interpolate x given y, or 5 to interpolate y given x. We'll go in the next module for interpolation. So I think okay, this is for nonlinear relationship. So nonlinear relationship, for more complicated, just we have to linearize them. So if we have exponential, okay, exponential is y equal a times e power bx. So we can linearize by len. Also in case of power, we can linearize by log. And for saturation growth, this is my equation. So if I divide each one over 1, so we just make the invert of each one, so it will be like this. So each one of these parameters is linear. Ln y equal ln a plus bx. So here is also log y equal log a plus b times log x, and here we have 1 over y equal 1 over a plus b over a times 1 over x, and each one of them is linear, so you can apply the previous steps. So this is last thing, and thank you so much. I hope you find it useful and helpful, and see you in next. Thank you so much. Assalamu alaikum warahmatullah.